Starting on year 10, today we're doing volume of a sphere, and the formula that you're going to be using for this one is up here, okay? So the volume is 4 over 3 pi times the radius cubed, so it's similar to the area of a circle type thing. This is very, very simple, this one. All you have to make sure is that you have the actual radius, okay? Now remember, the radius of a circle will be the distance from the centre of the circle to the outside. So the radius of a sphere is exactly the same. It's just the distance from the centre to the outside. So all you have to make sure is that before you plug anything into this formula, do you have the radius? So to have a look at the first, there's basically 4 types of questions. These ones are all very, very similar to doing that one. Just whether or not you've got the radius and how they want the answer given. And then the last type of question is about working out a hemisphere. We'll come to that later on. Okay. So what I've done, you've got a your turn, worked example, your turn each time. So we'll do this exactly the same way that we would do in class. And then you've got it set on Hegarty Maths for you as well. So is this 5? Does that go from the centre of the sphere to the outside of the sphere? Yep. So that means that the radius there is 5, which means I can just put that 5 straight in instead of the radius in my formula. So I'm going to get 4 over 3 times pi times 5 cubed, and I just put that into my calculator. Okay, 4 over 3 times pi times 5 cubed, and it gives me 500 over 3 pi. But remember, we're paying attention to what it's asking us for there. It wants 1 decimal place, so I need to press that button and it turns into 523.59877756. Now if we went it to 1 decimal place, it's better with this light on actually. If we went it to 1 decimal place, it means we're going to have to chop it after that 5 there. So what we always do is look at the number directly next to it. If that number is 5 or more, then this number that we're chopping it off after goes up. If it isn't, it stays as it is. So because that's a 9, that 5 will go up to a 6. So the answer to that one is 523.6 centimetres cubed. Okay, so can you have a go at this one? So in your home learning books, just draw out that as an example and have a go at doing that. Ask yourself, is that the radius of the sphere? And if it is, just plug it straight into there. Okay, just pause the video, have a go at that, please. Okay, so that is the radius. So your radius there is 7. So what you should have been doing is 4 over 3 times pi times 7 cubed. So again, putting that into your calculator, 4 over 3 times pi times 7 cubed. And that gives you 1372 over 3 pi, or to 1 decimal place, your answer there would have been 1436.8. Because again, chopping it after the 7, which is in the first decimal place, got a 5 next to it, so it goes up to an 8. Right, so give yourself a tick if you got that one right. Right, the second type of question, which is questions 3 and 4 on the Hegarty Maths, looks like this. Now, what do you notice about the comparison between this one and this one? Well, the distance this time you're given right the way across the sphere, aren't you? Which means that is the sphere's diameter. So the diameter is 30. We need the radius to be able to use in our formula. So if the diameter is 30, what will the radius be? It'll be 15. Now we know the radius is 15. It's just exactly the same as the one above. So we're going to do 4 over 3 times pi times 15 cubed. And again, just put that all into your calculator. Pi times 15 cubed. And we get 4,500 pi. And this time, it's asking us to leave our answer in terms of pi. So that's, just leave it like that. Okay, don't need to press SD. When it says in terms of pi, it just means that it wants a pi in the answer there like that. Okay, so pause the video, please. Have a go at this one. That says 50 on it. Apologies for me writing. Okay, so what you should have done here was the diameter there is 50, which means the radius is 25. So you're working out should look like this: 4 over 3 times pi times 25 cubed. We've got 4 over 3 times pi times 25 cubed. which gives us 62,500 over 3 pi. Let me just leave it like that. Okay, so if you got your answer like that, it's fine. If you did write it as a decimal there, you would have got that 65,449. It does though ask for it in terms of pi, so make sure you're paying attention for that, because a lot of the work that I'm seeing on Heggerty, people are getting that wrong. Okay, so even though you're doing the right thing, please try to make sure that you can spot that. Is it asking me for decimal places? Is it asking me for significant figures? Is it asking me for it in terms of pi? Because that is important. Okay, right, and the next type of question, again, very similar. Work out the volume of the sphere, and again, it's asking for it in terms of pi, so we know we're not going to write this in decimal places or anything. And this is saying, this time it just gives you the height of the sphere. Well, the height of the sphere being 16, I want the distance from the centre to the outside. Now, usually we would draw the centre to the outside sort of across like that, but if you think about it, it's the same in any direction, isn't it? So if from there up to there is 16, what would that be? Because that would be the radius from the centre to the outside, so from the centre to the top. Well, if from the bottom to the top is 16, from the centre to the top must be 8, mustn't it? So that effectively, that 16 is effectively your diameter. So your radius is 8. So again, we're just using our formula, 4 over 3 times pi times 8 cubed. 4 over 3 times pi times 8 cubed into your calculator, and we get 2048 over 3 pi. Right, and that's our answer. So can you not have a go at trying this one, please? Exactly the same type of thing. That says 12 centimetres. Pause the video, have a go with that. So what you should have spotted there, your diameter is 12, which means that your radius is 6. So you should have been doing 4 over 3 times pi times 6 cubed. Into your calculator. Do you know what I'm going to start doing? Just deleting this. Remember, if you've got one of these calculators, you can just go back in, because it's the formula that you're using each time, and you're just changing that one. You can just go back and just change that to a 6. So that gives me 288 pi. Okay, so that will take you up to question 6, just using the formula. Now, the last couple of questions are about hemispheres. Now, a hemisphere is half of a sphere. That's what hemi or demi or anything like that means. Okay, if you think about like the northern hemisphere, that's everything above the equator. Southern hemisphere, everything below the equator. So that's effectively what this is. This is part of a full sphere that has been chopped in half. Now, the way that we do questions like this with any shape is you figure out the volume of the shape that would have been there and then half it. Okay, so we need to figure out the volume of a sphere that would have had diameter 16, and then we are going to half it at the end. It doesn't mean that we half 16 at the beginning or anything like that, or the formula changes. We figure out the full volume and then we halve it. Okay, so the distance from there to there is 16. That right the way across is the diameter. So the radius would be 8. So the full volume, I'm going to write this down. You don't need to write these kind of words down, but the full volume, I'd be doing 4 over 3 times pi times 8 cubed. Okay, so 4 over 3 times pi times 8 cubed, which gives me 2048 over 3 pi. 2048 over 3 pi. And then I want to divide that by 2. Now, it's up to you how you do this. You can either get this as a decimal first and then halve it, or you can just put divide by 2 into the calculator and halve it. I think given that some of you might be using a computer, we'll write this properly. We want it to 3 significant figures, this. So that's 2114. In fact, you know what, let's just write that out. 2144.66 for the time being. We put little dots like that to say we haven't actually rounded that properly yet. But because we want the hemisphere, that's the full volume, so we're going to then divide that by 2. So on your calculator, don't worry about putting this back in again. So you've got it on the screen there. Just press the divide by 2 button, and the calculator remembers your previous answer and puts it there. So that gives us 1072.33. Okay. Now, to 3 significant figures, that means that I would have 3 digits and then all zeros. Okay, so it means that I'll want this digit, and this digit, so those first 3 digits there. Okay, so I'm going to round it to whatever column that finishes in. That finishes in the tens column. That's 7 there. So I'm going to round that to the nearest 10. Does it go up or down? Well, it's going to go, well, it's going to stay at 7 because that isn't 5 or more. So that ends up being 1070. It's a 3 significant figures. Meters cubed. I should have written that on all of them really. Okay, so can you pause the video and have a go at this one, please? Exactly the same, except you're starting with a diameter of 24. So figure out the full volume, half it. Okay, so what you should have noticed there was that your diameter is 24, which means your radius is 12. So the full volume is 4 over 3 times pi times 12 cubed. So we get 4 over 3 times pi times 12 cubed, which gives us 7238.22. So we then need to divide that by 2 because it's a hemisphere. So we'll divide by 2, which gives us 3619.11. So then to 3 significant figures, that means we'd want those 3 digits, that one, and that one. So we're going to round to the nearest tens column again, which is going to give me this time, because it's got a 9 next to it, I'm going to round up. So that's going to give me 3620 meters cubed. Okay, so make sure all that's in your books for us, please, and then can you go and have a go at the Hegarty Maths clip on spheres that I've asked you to do. Okay, good luck, and any issues, just drop me an email.